Hello everyone, my name is Nizafillah bin Anwar. I'm a student from University Technology Mara, Shah Alam. My supervisor is Dr. Eran Sadiq Said bin Sadiq. My topic for H3 competition is Flood Vulnerability Assessment in Kuala Krai, Kelantan. Overview. There consists of several subtopics. The first one is introduction, background of study, problem statement, aim and objective, scope of study, literature review, methodology, result and analysis, conclusion and recommendation. For introduction, what is flood? A flood is an overflow of water that submerges lands that is usually dry. Floods are an area of study in the discipline of hydrology. They are the most common and widespread natural severe weather events. Flood can look very different because flooding covers anything from a few inches of water to several feet. They can also come on quickly or very gradually. Background study. They consist of three background of study. The first one is flood are one of the natural calamities that can strike at any moment as a result of weather. Floods are one of the most common and damaging disasters, claiming lives and causing serious economic damage all over the world. Second is monsoon flood and flash flood are two forms of flooding that commonly occur in Malaysia. The third is Kelantan is one of the area that has been severely impacted by the massive flood catastrophe that has struck Peninsular Malaysia East Coast. Since 1927, Kelantan has seen massive floods with a rainfall return cycle of around 1 to 1000 years. Problem statement. There are three problem statements. The first one is according to prior study, flood puts people's life and property at danger, and this is due to the difficulty in identifying flood vulnerable area. Second is there is a need for more information regarding flood vulnerability because it is the fundamental cause of disaster. Third is Kelantan economy has changed dramatically as a result of growing urbanization. Land development activities and environmental degradation are caused by urbanization. These activities have generated issues and had an influence to flood. Aim and objective. For the aim for the study is an assessment of flood vulnerable area based on topographic, land cover and climatic factors in Kuala Krai, Kelantan using Geographic Information System (GIS) and remote sensing. There are three objectives. The first one is to determine the causative factor of floods such as land cover and calamity in the area of Kuala Krai, Kelantan. Second is to analyze the flood vulnerable area in Kuala Krai, Kelantan by using weighted overlay spatial analysis. Third is to produce flood vulnerable map in Kuala Krai, Kelantan. Scope of study. The study area is in Kuala Krai, Kelantan. The district is located in the center of the state of Kelantan in Malaysia's northeast. The land has the confluence of two large rivers, the Lebir and Galas, which created the Kelantan River. Literature review. There are three literature review. The first one is flood typically occur when water runs over the banks of river and drainage canals, inundating the surrounding lands called floodplain. Second is the floods in Kelantan state were caused by a mix of physical reasons like elevation and closeness to the sea, as well as high rainfall during the monsoon season. Third is the land use data, amount of rainfall data, and digital elevation model (DEM) data were used to produce a vulnerable flood map for the study area. For the software, I'm using one of the H3 product, which is ArcGIS Desktop. So what is ArcGIS? ArcGIS is a Geographic Information System (GIS) software that allows handling and analyzing geographic information by visualizing geographical statistics through layer, building maps like climate data or trade flows. used by a whole host of academic institutions and departments both in the humanities and science to develop and illustrate groundbreaking research. Further, it is used by several government and private or commercial institutions worldwide. The system has the capability to create geographical information accessible throughout a company, institution, privately or public on the interest. Therefore, the software essentially works as a platform whereby geographical information can be linked, shared, and analyzed. Data collection. It consists of two types of data, which is primary and secondary. For primary, a survey on expertise to evaluate the criteria for flood analysis by using pairwise comparison questioning. Secondary data is satellite image, Landsat image of years 2014 and 2020. DM data, Kuala Krai, Kelantan, and rainfall data, Kuala Krai, Kelantan, rainfall of the year 2020. Flowchart of methodology. Okay, by using satellite data, Landsat, SRTM, the satellite image is processed by using supervised classification to produce land use and cover. And by using satellite data also, we download the DAM and process by using spatial analysis tools to produce flow information. By using the, and also we can create a slope and elevation. Okay, for hydrological data, rainfall is processed by using spatial interpolation to get the average rainfall. And after that, by using weighted overlay to produce flood vulnerable map. Determining the criteria weight. For this research, the element that influence causes of flood are the criteria used for making an analysis. An analytical hierarchy process, AHP techniques, used for developing the hierarchical structure representing the problem. Continue with pairwise comparison method. It chooses the best criteria from a pair and rate the degree of importance elements. All the elements, including land use, elevation, slope, flow accumulation, and rainfall, need to identify by the expert using this method to deriving the rating for overall priority. Hierarchical structure AHP that consists of 5 criteria: land use, elevation, slope, flow accumulation, and the last one is rainfall. Okay, this is the questionnaire for pairwise comparison. The first one is for main criteria C1, C2, C3, C4, and C5. Second image is the survey form is used to compare each criteria in the section. The criteria will compare based on this comparison scale below. The scale is 1 to 9, from equal important to extremely important. And on the right image is the question in the questionnaire, the sample of question. A pairwise comparison, this is the result. For the result and analysis, multi-criteria analysis result. Okay, these are the results from previous pairwise comparison. Table 1 shows weightage for each criterion. Column W contains criteria weights. This is a measurement of how much each criterion has an impact on floods in the study area. C3 slope has the highest weightage with 41%, and C4 calculation has the least weightage with only 5%. Criteria of flood vulnerability. The main flood causing factors are land use, elevation, slope, flood accumulation, and rainfall were used for inundation of flood vulnerability. Land use, land cover. Human activities such as deforestation, development, agriculture, and others, which tend to make a big difference in changing land use, land cover, LULC, were supported by Kelantan increased growth rate. The land usage of Kuala Krai had been identified for several classifications depending on their color. Figure 1 and Figure 2 shows land use, land cover for years 2014 and 2016 of 5 classification classes, which are water body, forest, agriculture, built-up area, and cleared land. The results show that the most of the classification have increased land use changes, except for the forest and cleared land, which has decreased. Okay, land use land cover. Figure 3 is the percentage of spatial area change, and table 2 is land use level of influence to flood risk. Furthermore, using the data of attribute table, Figure 3 shows a graph in the form of percentage to illustrate the changes of area between the year 2014 and 2020. Forest was the largest area recorded for 2 years compared to other land use. In 2014, agriculture was lower with 3.51% compared to agriculture in 2020 with only 10.41%. Besides, the built-up area was increasing from 13.58% in 2014 to 21.31% in 2020. This was due to the development of urban area that rises every year corresponding with rise of population in Kuala Krai. Figure 4 is the reclassified land use of Kuala Krai, Kelantan 2020. Next, the land use land cover map reclassified into 5 categories from low to high influence of flood risk. Table 2 shows the land use level from very low to very high. Figure 4 shows the reclassified land use map of Kuala Krai, Kelantan 2020. Rainfall distribution. It was possible to predict the level of flood risk by determining the amount of rainfall. Amount of rainfall was used to forecast floods in the present and future. Figure 5 shows yearly amount of rainfall in Kuala Krai, Kelantan. The rainfall map created a continuous raster rainfall data within and around the administrative border using gradient analysis. Then, amount of rainfall was classified into 5 classes using equal interval with different color for each class. Furthermore, the rainfall map reclassified into 5 categories from low to high influence to flood risk. Figure 6 shows reclassified rainfall map of Kuala Krai 2020. Excessive rainfall can cause the river levels increasing and when it over the riverbank. The nearby area potentially vulnerable to flood. Slope and DEM. The slope map simultaneously displays the slope, which is the steepness of continuous surface, such as terrain, represented in digital elevation model (DEM). Figure 7 and 8 shows slope degree map and digital elevation model values in meter. Based on the result below, Kuala Krai area mostly has low land area in the area. In the map, low degree level of slope area represented in green color, which unfortunately was where most of the built-up area located. Elevation and slope are important factors in determining a terrain stability. The direction and amount of surface runoff or subsurface drainage that reach a place was influenced by the slope. Reclassify of slope and DM. In addition, the slope and the DM map was reclassifying into 5 categories from low to high influence to flood risk. Figure 9 shows reclassified slope map of Kuala Krai, and figure 10 shows reclassified DM map of Kuala Krai. Flow accumulation. Figure 11 shows the flow accumulation map with 5 classes. Grey color in the map was the lowest flow accumulation compared to others. The highest value was with yellow color. Apart from this, flow accumulation map was reclassifying into 5 categories from low to high influence to flood risk. Figure 12 shows reclassified flow accumulation map Kuala Krai. The very high level in the reclassified flow accumulation map was possible stream channel in an event of water runoff. Because its densities indicate the essence of the soil and its geotechnical characteristic, drainage was a key ecosystem in controlling risk. Weighted overlay spatial analysis technique. This is the final stage of the processing. The data is used to overlay command and assign a color ramp in order to show physical and climatic factors and Indonesian area layer to graphically display places that have vulnerability to flood. All the data that has been processed will through the weighted overlay analysis, a tool in ArcGIS desktop software. The weighted overlay analysis is used to overlay land use, average amount of rainfall, slope, and DEM and flow accumulation based on the scale and weight that has been identified by experts in the multi-criteria decision analysis (MCDA). From here, every criteria has a role in order to develop the final map. This analysis based on 1 to 5 that represent from lower to high vulnerable area to flood in the study area. Figure 13 shows spatial analysis tools, weighted overlay. Moreover, figure 14 shows output of the weighted overlay. Final output. Flood vulnerable area in Kuala Krai, Kelantan. Flood vulnerability area map of Kuala Krai, Kelantan was created based on percentage value of each criterion. Figure 15 shows the map of the flood vulnerable area in Kuala Krai, Kelantan. The color indicates each 5 classes of flood vulnerability in Kuala Krai, from lowest vulnerability area to higher vulnerability area to flood. The reasonable vulnerability represented as yellow color has covered several locations in the map, while very low vulnerability was the least dominated area. As can be seen in the map, most of the area of in Kuala Krai was in high vulnerability. Based on figure 15, the flood area with high vulnerability, which in red and orange color was surrounding the river along the area that has high vulnerability and also in lower slope and elevation. We can conclude that meteorological, topographical, and hydrological influence the flood vulnerable area. Conclusion and recommendation. Conclusion. Flood vulnerable mapping is an important component for land use planning in flood-prone areas. It can guide the effort of town planner and administrator to prioritize their mitigation and relief response. Flood vulnerable mapping in this thesis is to show the portrait flood-prone area in Kuala Krai, Kelantan. It has been achieved through the multi-criteria analysis (MCA) techniques using GIS overlay analysis application. Based on this study result, it can be concluded that each of the criteria applied in this research, such as land use, elevation, slope, drainage, and rainfall, have its own importance based on the weight and GIS based multi-criteria analysis (MCA) techniques in order to solve decision problem for the decision makers. To identify the area of flood vulnerable, the suitability criterion is needed to make a weight calculation and comparison. Besides, several GIS operation and image processing are employed in the methodology. As a result, a prediction can be made and a potential flood vulnerable map can be created. From the resulting map indicate that more than 50% area in Kuala Krai, Kelantan are exposed to high vulnerability to flood. As a conclusion, all the objectives in the study has been achieved. The first objective was to determine the constitutive factor of flood has been shown in preliminary study to determine criteria in floodability. Moreover, the second and third objective are achieved where the GIS-based vector overlay analysis has been conducted using criteria weight that has been calculated and produced the final product of flood vulnerable map in the area. Recommendation. Based on this study, there are several recommendations that can be applied in the future in order to improve the result of the analysis. In the study, is focusing to determine the area of vulnerability by using an analytical hierarchy process (AHP) to evaluate each criterion. Other criteria suggested that can be added into this study is type of soil. Type of soil also influence to flood vulnerability. Water cannot infiltrate impermeable soils and rock such as clay or shale, forcing water to run off, reducing river lake tides and increasing flood risk. Moreover, it is recommended to use high-resolution imagery such as aerial photogrammetry. High-resolution imagery is necessary for obtaining a clear visual of the extent of vulnerability, as well as for producing more accurate results. In addition, aerial photogrammetry is an accurate and powerful tool in surface model generation, extracting high resolution EM. Okay, that's all from me. Thank you for watching.